morning, students. In our last session we have discussed related to the CNC programming. So in today's session we will see some of the CNC programs related to this topic. So here we are going to have some of the part. It is one of the part where how we can go for the programming with respect to this. For this we are having a tool size which of 0.25 inches, feed rate 6 inch per minute, cutting speed 300 rpm, tool start position from 2 and 2, programming in inches. Programming should be in the inches. It is one of the example how we have to go for the programming. So the tool has to move from P0 to P1, P2, P3, P4, P5 and again P1 and P0. So like this the tool has to move. Motion of the tool should be in this direction. So we are having 5 inches here, that is 0 to 0, P0 to P1 it is 2, we are having 2 and 2. From P1 to P2 it is 5 inches, P2 to P3 it is 2.5. In the same way P3 to P4 we are having a radius which is of 1 inch, and P4 to P5, P4 to P5 that is about 2.5 we are having again, and P5 to P1 which is 4 and 4, and P0. In the same way for this he has given you the angle of 45 degree. So by using this we have to do the programming. So we see this one. So first is we have to set the programming parameters, that is N0 or N10, that is nothing but the sequence of operation, that is 10, G70 which is programming in inches, and G90 which is the absolute coordinate system, and G94, G97 which is the feed in inch per minute, and M4 which is the spindle speed in RPM. So like this, spindle in clockwise direction is given. Next machining condition, that is G17, that is the N20 sequence, and G70 which is machine moves in XY plane. G75 that is the full circle interpolation, that is the circle what we are having, that is G75. F6 is the feed rate, and S spindle speed. T is the tool change 1001, tool number 100, and tool number is 1. M08 that is the coolant off and on we are having. So now move tool from P0 to P1 in straight line. So P0 to P1, P0 to P1 the tool has to move, that is P1 that is with respect to the P1. So here we are having X is of X is equals to 4, that is minus 1.25, that is 3.875, and Y is 4 minus 1.125 of tan 22.5, that is he has given 45 degree, so it is of that is divided by tan of 222.5 which is 3.698. So here that is linear interpolation, that is sequence is N30, and G01 interpolation, and X is 3.875 and Y is 3.698. So it is the coordinate what we are having. You can see here the target coordinates, that is X 3.875 and Y is 3.67. How this 3.875, that is X is equals to 4 minus 0.125. So here we are having 4 and 4. By taking this 4, that is minus of this 0.125 divided by tan of 22.5. So by applying the tangent coordinate we are going to have this one. So 0.125, here we are having 0.125, and that is divided by tan of this tan of 22.5, that is 45 we are having, that is 22.5, that is 3.689. So this is what coordinates we are going to get. In the same way profile from P1 to P2, that is N40 sequence, and G01 linear interpolation, and X is 3.875, and it is a continuation of this where we are having 3.695 plus next that is 5, that is what we are having. So that is 9.125, or it is y 9.125. So x coordinates do not change here, so we are not x coordinate do not changes here, it remains constant. Only the y changes because the tool has to move from P1 to P2, that is 5 inches. So plus 5 for this, it gives you 9.125. so no need to program it here, so x is not required, so we can give only the y, so that the tool moves from P1 to P2. So in the same way, that is P2 to P3, we want here, so linear interpolation, and it is for next, that is x is here we are having x y will be same, y will remain same, whereas x it has to change, that is 3.875 plus 2.5, which gives you 5.634. so this is the target what we are having. So and y, that is y is equals to 9 plus 0.125, that is 9.125. so we are going to have here 1 inches, that is we are having, so with respect to this, y is equals to 9 plus 1.125, that is 9.125. We are going to have x is equals to 5 plus, because we are having 6.5 minus x, we are going to have, that is x plus 0.125. so we are going to have x is equals to 5.634. we are going to have x is equals to 5.634 and y is equals to 9.125. so this is, and in the same way that is 3 to 4, that is we are having n60 g03 and x is equals to 7.366 and y is 9.125. so this is the target coordinates where we are having the circle, so I, j and k we have to represent. So I that is 6.5 and j is 9, so that is the coordinate of center of the circle. So that is what we are having, and from P4 to P5, that is linear interpolation we are having, that is with respect to P4 to P5. so x is equals to 9.302, where y is unchanged here, it remains constant. So 5 to 1, where here x is 3.875 and y is equals to 3.698. so it is the next what we are having. So and next return to the home position and stop the program. So that is n is equals to 90 and g01 linear interpolation, and x is equals to y is equals to m30, end of the data, that is m00, that is the stop of the program here. So this is how we have to do the programming for this. So the complete programming, that is all the n10, n20, 30, 40, 50, 60, 70, 80, 90, that is the different set of the sequence of operation with respect to this. We are having here all these coordinate with respect to this above profile can be done with respect to this. So this is what we are having. So next I'll go with a simple one of the problem here. So this problem where it is which is of on CNC lathe, it is on CNC lathe. So here you can see here, so for this we are having from it is in a z direction, it will be in z direction, and it will be in the y direction, and the horizontal will be in the y direction, and it is the x direction. Vertical will be x direction, horizontal will be y direction, and z direction will be in the axis direction. So this is what we are having. So the tool is at 50 mm from the z direction it is having, and from 50 mm it has to go to B, C and D, like this it has to move, and again it has to come to the point A. So when it has to move, we are having 50 mm from the tool to B, which is 50 mm, C it is 80 mm, and for D it is 100 mm, and the diameter is of 50 and diameter is of 80 mm, diameter is 80. So for this we have to do the programming here. So I'll explain this how to make this one. For this we have written the program, that is part program n5, 10, 15, like this we have to go with respect to 5, 5, that is the sequence of operation which is given in 5, 10, 15, 20, like this. If you want to enter any of the in between, if you want to add, we can add that one. Because of that we are taken it as n5, 10, 15, 20. So here n5 and m12, which is nothing but here n5 clamping workpiece. Next it is n10, where changing of tool 1, changing of number one tool and executing its offset, and N15, that is G0, N15 where rapid positioning, G0 is a rapid positioning to a point A, that is to point A. So point A is nothing but this one, point A is with respect to this, so it is rapid positioning of the tool with respect to the point, A. So here we are having x 100 and z is 50. So x 100, for example, it is x 100 and z, that is 50. Okay, so this is what we are having. Next N20, next we are having N20 M3. M3, what we are having, that is the spindle starting of the spindle with respect to 600 RPM we are having, and N25, it is coolant on. M8, what we are having is the coolant on, and M30 N30 where the G1, that is the in N30, that is G1, that is approaching to the N30 approaching to the point B. It has to approach to the point B here. So when it is approaching to point B with 600 mm per minute, it has to approach to the B here. So when it is approaching with respect to the B, we are having here it has to move x direction, it has to move 50 mm, so we are having a that is with respect to this, it has to move 50 mm. Okay, it has to move 50 mm, it has to move to point B is here, so it has to move to point B. So from here it has to move for 50 mm. So x is 50, z is 0. Here we are having z is 0, x, it has to move here, from here to here it has to move 50 mm, where z is 0 and feed rate is 600 RPM. So, that is 600 feed rate, feed rate, it is feed rate, that is 600 mm per minute. And N40, next is we are having N40 where in N40 cutting from point, that is B point to C point. So cutting from B point, that is B point to C point, it takes place here. So that is B to C, that is Y, which is 30 mm. What we are having is minus 30, Y is minus 30 here, so it has to move with respect to this. So here we are having, that is 30 mm, it has to move for 30 mm, that is 30 mm, which is Y direction. It is Y direction, he has taken this as Y direction, and it is of X direction. So Y direction, it has to move for 30 mm, and with the feed rate we are having a F, which is 200, and next it has to move to the next one, that is we are having N50 where X is equals to 80 and Y is minus 20. So X is 80, it has to move to the 80, and that is 50 plus 30, which is 80, and where it is having the Y is equals to minus 20 here, so it is having minus 20, it has to move to the minus 20, and feed rate is 150. So feed rate decreases here because of we are having a taper, so it is 150. And in the same way N60 G0, that is N60, that is rapid retracting to point A. It has rapid it is moving towards the point A, So after doing this, it moves to the point A, that is point A, that we are having 100 mm, X is of 100 mm and Z is 50. So Z is 50, and X is equals to 100 mm. And next is N70 where cancelling the tool offset, N80 which is stopping the spindle, and N90 coolant off, N90 which is coolant off, N100 releasing the workpiece, N100 M13. So N100 and M13 which is related to the releasing the workpiece, and here M9 which is the coolant off, stopping the spindle, M5 is stopping the spindle. In the same way M30 where end of the program, stopping that is the spindle should stop as well as coolant should off. So that is the M30 here. So this is what the program we are having with respect to this turning operation. So now we are having CNC milling. We are having another example of CNC milling. CNC milling here. So this is the program with respect to this, where we are having N5, G90, G71. So what exactly this we'll see the diagram here. We are having 150, it is 20. Here we are having 30 home position, which is 100, which is having minus 100, and 86 and 95. 86 and 95 from this position is given, and it is 30 and it is 70. Here we are having 10 mm from here. It is 60 and it is 10. So radius, it is 80 mm radius and 50 mm radius it is having. So we have to do the milling for this one. So first N5 G90, N5 G90, N5 sequence of operation N5, and absolute positioning. G90 is absolute positioning, which is in terms of metric unit. So G71, which is in a metric unit, and N10 where we are having tool change to T1, tool change to T1. N15, that is N15, that is define work 0 point at A. It is at A. We are going to have at A. So it is this point, A point. So N15, that is we have to position the workpiece. We have to position the tool with respect to this one. We are having home position, that is 100, minus 100, 86 and 96. From here it has to move to the point A here. So that is what we are having. So G92, and X is of minus 100, X is of minus 100, and Y is 86, and Z is 95. Z is 95. So if the tool moves from this position to point A. So N20, that is G0, where X is 0, Y is 0, spindle speed, which is 2500 RPM, and M3. So here M3, which is that is the rapid traverse to A, spindle on it is. So spindle has to rotate at 2500 RPM in clockwise direction. Next we are having N25. We are having N25, where rapid plunge with respect to the, that is 12.5 mm above, that is Z will be 0 here. So we are having N25, where Z is equals to, so Z is minus 12.5, we get 12.5 here. So it has to move here. And N30, feed to, that is Z minus 12.5, and feed rate, which is of 150 mm per minute. And N35, we are having N35 and N35 X20 and Y30 we are having. So what is this N35? So which cuts a line, that is from AB, which cuts a line to AB to B. So AB to B, it cuts here. So we are going to have minus 20. We are having minus 20, so it has to move 20, that is minus 20, and Y is 30 mm. So the tool has to move from 20 in the opposite direction, that is minus, and above this, that is A to B it has to move, so it is 30. So Y is 30. So and in the same way we are having N40, that is G2X10, Y100, and radius is 80 here. So which is of it has came here, and it has to move with a radius of 80 mm, with 100, because from here to here it is 100, that is 70 plus 30, which is 100, and X is 10, in X direction it is 10. So X direction 10, Y direction it is 100, and radius is of 80. So the point is right at the C, point C. So in 45, N45 which cuts C to D. C to D it cuts here, C to D, CD to D where it cuts. So where G1, that is X, is 140. We are having here from here to here which is 150, but here we are having 10 mm. So 140, X is 140 and Y is 60. We are having here 60. So C to D, if you want to reach this point, it is 60 mm. So Y is 60. So N50 where cuts an arc of D. This arc it has to cut here. So when it has to cut this arc, so that is what we are having. So it has to cut the, so we are having 150 and Y is of, it is 150 and X is 150. From here to here it is 150 and Y is 0. It is X only, Y is 0, and we are having a radius of 50 mm. Radius is 50 mm. And in the same way, next we are having N55 and G1, where we are having G1 and we are having at this point right now. So it is X0 and Y0. Again we are going to have here, so X and 0 and Y is 0. That is what we are having, which cuts EA. It has to cut EA here. So from here to here it has to move here, EA to, so N60 rapid retract to Z12.5. So it has to retract to Z12.5. It has to retract. We are having 70. So it is retract at 12.5 mm. And N65 reference point return in Z direction, that is spindle off. It has to move with respect to the position. So that is G28, Z is 0 and M is 5, where it has to go for the reference point return in Z direction, and spindle should be off. And N70 reference point return in X and Y direction, and N75 and M30, that is end of the program. So this is how we have to go for the milling operation. So in the same way we are having a example on drilling. We see the drilling operation, how to make a code for this one. So we are having a drilling operation here, where which is having so here we are having 4 holes which has to be drilled at a distance of from the point, it is of 0.5 and 1 inches, 0.5 and 1 inches. Here it is 0.5 and 1, but the drilling depth is of which is of 0.375, and it is having a thickness of 0.5. Okay, so for this we have to go for the operation. So we are having a program here, N1 N1 sequence of operation N1 T16 M06, where N1 which is of tool change, that is of M06, that is tool has to be changed to tool number 16. So tool has to change here. So that is what we are having. N2 G90, that is tool rapidly moves to 00, and the first drilling position what we are having, which is of 0.5, X is 0.5 and Y is 0.5. So we are having, for this it has to move from here to here. So it is first hole which is of 0.5 and 0.5, while taking into account of 0 offset. So we are having 0 offset, and that is number, that is G54. So G54, that is nothing but the that is the 0 offset number for that one. And next we are having N3 what we are having is the spindle speed, that is 1450, that is of the drill starts rotating, that is clockwise direction with a speed of 1450 rpm. And N4 drill takes depth of Z1. So taking into account of tool length compensation, we are having the that is we are having that is H that is G43 H16 that is coolant is turned on with M08. So H16 and Z1 we are having. So N5 drilling cycle, that is G81, that is the parameter what we are having. Drilling cycle, drill depth Z and cutting feed ZF are given with this command for this current position, that is X.5 and Y.5. So N6 what we are having is as drilling cycle continues, its work with every axis movement. So next drill is done at next drill, which is at X1.5. So X1.5, so here we are having X direction, so from here to here it has to move with respect to 1.5. so from here, so if it takes in X direction, so it is 1.5. so X direction which is 1.5. so X direction which is 1.5, and in the same way N7, that is my Y is equals to minus 1.5. in Y direction, when we take Y direction which is of 1.5, so X direction and Y direction we are having. So when it moves to the third point, which is minus 1.5, third drilling hole which is of minus 1.5 it is having, and the fourth drilling which is of 0.5, so which is of 0.5 X direction which is of 0.5 mm, 0.5. So N9 we are given as N9 G80. So N9, that is drilling cycle is cancelled at G80, coolant is turned off here. So N10 that is taking machine coordinate system G53, and into account the drill is taken to Z0 position. So tool length compensation is cancelled, that is G49. So cutter rotation is stopped. So M05, which is cutter operation, is stopped here. So N11 where CNC part program is ended here. So this is the programming how we have to do for the drilling operation. So it is a simple programming what we are having with respect to this. Okay, so this is the drilling operation programming what we are having. So for this I have written we are having all the programming here. So in detail we are having the programming, so please refer this one. And for this at the end we are having one assignment here. So typical programming, that is for the turning operation. So for this you have to write the program. So write a part program for a turning operation being carried out on a CNC turning center. So let us take an exercise of this one. So this is the final profile to be generated on a bar stock by using the CNC turning center. So after studying the required part geometry and figure, the main program can be written as follows. So here we are having it is diameter 70, we are having 15, 40 and 20. So raw material, that is MS bar of diameter 70 mm and length of 160 mm. So the diagram is not to scale here, so we'll leave all this. So we are having all this. With respect to this, you have to do the programming for this one. So I request all the students to do this assignment and submit in time. So this is the last topic what we are having in the CNC programming. So in our next session, I am going with the automation with respect to the CNC machines, or it may be the automation part with respect to the machines, or it may be the layout, everything. So automations, how the automations are running, so we'll discuss about that one in our next session. So thank you, students.